So, welcome back. I know you think since we're working on chapter 14, that means this is the end of geometry, and wouldn't that be nice? However, it is not. We'll go ahead and we're skipping to chapter 14 because there are only a few sections in chapter 14 that we're doing, and we're going to cover most of them today, actually, and then tomorrow we'll do another section, and then we'll be done with chapter 14. So, back to a highlight video, which means there isn't too much for you to worry about as far as things that you need to have memorized. But these are the highlighters that I'm using. Remember, yellow is for definitions, purple is for postulates and theorems, and blue is for information. It's good to know, but doesn't necessarily need to be memorized. Okay, so let's get started. I am looking on page 586. Down at the bottom, they start talking about something called a mapping. And we're going to talk about these because they get to be really important when you get into algebra again. But what you really need to understand about a mapping is that what happens is each part of A corresponds to one and only one member of B. So let's look at some examples up here on the next page. So here we have A on this side and B on this side, and this tells you it's a mapping from A to B. And this one really is a mapping from A to B. All members of A map on to some members of B. That's what they're saying. But in order for it to be a true mapping, that means that each member here only maps to one member there. So A will only go to D. A can't go to E, and A can't go to F. It only goes to D. B only goes to E, and C only goes to F. When you look at B, you see that that's true too. A goes to D, B only goes to E, and C only goes to E. That's okay in a mapping, as long as each member here only goes to one member here. For C, we have each member here only going to one member over here. Now nothing goes to F, but that's okay. For D, we have some members here that go to two separate members there, so D is not a mapping. Now that you understand kind of what a mapping is, and it'll always look like this, it'll always have one circle here, one circle there, and something going from here to there, okay? There's something called a transformation. A transformation is a mapping if and only if it is a one-to-one mapping. That phrase one-to-one means that not only, back up here, not only does A only go to D, but there is only one thing that maps to D. So only A goes to D. No other thing over here goes to D. So this one is not only a mapping, it's also a transformation. But here, there are two things that go to E. So this one may be a mapping, but is not a transformation. This one is both a mapping and a transformation, and this one isn't even a mapping. So if it's not a mapping, there's no way it can be a transformation. It has to be a mapping first before it can be a transformation. Mapping means it only goes to one thing. Transformation means only one thing comes to it. Okay, that takes care of that. They will talk about things in mappings like this down here, where it says a transformation of xy is equal to x prime, y prime. Xy is just like a point in the xy coordinate plane. but x prime and y prime is an image of what happens to that point once you put that transformation on it. So this one is your image, whereas what you're putting the image on is your pre-image. We'll talk about more about that in just a second. So I'm going to demonstrate that with this example too. When you look at it, hold on, help me out here. So when you look at this, you have a transformation of xy is equal to this. So once we take x and we add 1 to it, that'll become our image. The xy, whatever we start out with originally, is our pre-image. So it says the image of 2, 5 under t. So they want us to put 2 where x is and 5 where y is, and then tell them what that's going to become. So when I put a 2 in for x over here, I have to put it in over here too. 2 plus 1 makes it 3. And then when I put a 5 in place of y, 3 times 5 is 15. And that's your answer. That's what our new image is going to be if you take t, 2, 5, and put it under t. So here they went ahead and told you that x was your 0 and 3 was your y. So when you put that underneath this transformation, 0 plus 1 is 1, and 3 times 3 is 9. Over here, 3 plus 1 is 4, and negative 2 times 3 is negative 6. And the pre-image of 9, 4. So they're saying that they want to know what the xy was if this was 9, 4. So that means some number plus 1 is equal to 4. That means my some number must be a 3. And then some number times 3 is equal to 9. So that must be a 3. And you can look and see that those are all correct. That's how you figure out a transformation. That's the basic nut and bolts of it. Now, I don't know if you noticed this or not, but I did all that in blue, which means you don't have to have it memorized. Isn't that nice? But it is important information for you to know. So there is that. That's all you need to know out of 14.1. Moving on to 14.2, talking about reflections. A transformation is a reflection in a line if and only if it follows the following conditions that are satisfied. If A is a point of L, then the image of A is A prime. That's supposed to be A prime. That's what that little line means, A prime. If A is not on L, then the image of A is A prime, such that L is the perpendicular bisector of A and A prime. So if you look over here, it's just like you having a line, and you're going to project this onto a mirror, and you're going to see an image. So when you look at a mirror and you have your hand here, if the mirror is here, you'll see an image that looks like it's just as far away from here as this is from there. That's what a reflection does. It makes it look in the mirror like it's beyond the mirror. And that's okay. That's what this is. This is your mirror. But if you put your finger all the way up to the mirror, it looks like there's no room there for a reflection. So this will become your perpendicular bisector. The mirror becomes perpendicular bisector of that image. So basically, all you're having to do is reflect something across it. That's why we call it a reflection. And that line that causes that perpendicular bisector is called the line of reflection. Now, I don't care if you know their fancy stuff, the way they're doing it, but what I do care about is that you are able to figure out what the reflection looks like. So here this is saying if we reflect across K, so this is my K, and this is my L. So when they talk about reflecting across L, you'll know what that's talking about. So when we reflect across K, what does P become? If this is K and this is P, when I reflect across it, I have to do a perpendicular to it. So that's going to be R, because it's the same distance away and it's perpendicular to K. So this one's going to be R. When we reflect across L, that's this one, S, which is this point, becomes what point? Well, since it's already on L, it's going to be S. When we reflect L from P, it'll become point Q, because that's the same distance away from L, and it's perpendicular to it. That one is Q. When we reflect across LQ, it's going to be P, because it goes just the other side. When we reflect across K, S, which is over here, is 2 away from K, so we're going to have to go 2 away to get to our T. And when we reflect across K, N, since it's on K, is going to stay in. And you can look and see that we got all of those right. Then they'll want you to look at pictures to get reflection. This reflects to that. This triangle reflects to that triangle. This line reflects to that line. Most reflections you won't have a problem in the world seeing, and that is all you need to know about reflections. Translations. Last section we're doing today, by the way. Translations. If A and B are points, and A prime and B prime are their images under a transformation T, which is what we've talked about so far, then A is a translation if and only if all this stuff happens. There's an easier way of putting it. I'm all about it being an easier way. And that's right here. If a transformation T maps to any point x, y, then it has to map this way in order for it to be a translation. This way, so that you're adding something to both letters. You can't be multiplying to both letters. You have to be adding to both letters. If you can subtract, that's fine, because that's like adding a negative, but you can't divide and you can't multiply. So, if you look down here, they want to know if these three are just transformations or are they actually translations. So this one says that you do this to it. It has to be a transformation because it's got the big old T, but is it a translation? Yes, it is. Because we're adding something to both. First, we're adding 1, and then we're adding a -2 to the other one. Is B a translation? No, it's not, because now we're multiplying by something, and you can't multiply, you have to add or subtract. Is C a translation? Yes, it is. First, you're adding -3, and then you're adding 0. So that's all fine and good. That's all you really need to know about translations. Now, this is when I would normally give you classwork and homework, right? It'd be really nice of me to do that, wouldn't it? Really, really nice of me to do that. I have some problems here I could do that with. But instead of giving you problems here, I have a better place of giving you problems. By the way, no classwork today. All of it is homework. It's located on page 634. I did not stutter. That is the page that you're doing it on. And it is problems numbers 1 through 7 odd. That's it. I think you can handle that. They're not hard. Go forth and prosper. Understand that everything that we're talking about today is good information for you to know. Probably not going to make it on the test. I might have a problem up there about translations as far as you finding one, where I tell you that, like in the mapping one, where we had, where was it? This one, where I tell you a translation and I ask you about a couple of them, what it would be, but it's not going to get any harder than that on a test. So go ahead and do your homework, make sure you do well, and we'll see you next time. Bye.